So several talks today have already discussed the problems of fossil fuels. They're running out, they contribute to pollution and global warming. So today, I'm here to talk about making fuels from some alternative and unusual sources. What if we could take carbon dioxide out of the air and turn it into a useful chemical again, using just the energy contained in a scrap heap? Well, I work with microorganisms that we think might be able to do just that. They grow at extremely high temperatures, at least 70 degrees Celsius, which is about 160 degrees Fahrenheit, and can be found in environments like hot springs or hydrothermal vents at the bottom of the ocean. It turns out that in these high temperature environments, things that we typically think of as food, organic compounds like proteins or sugars, are pretty scarce. But what's plentiful are inorganic chemicals, like sulfur, which is visible as the yellow around the hot spring, or metal ions, forming the gray cloud above that hydrothermal vent. My microbes have evolved to extract energy from these chemicals because they're the only things around to eat. Then they use the energy they get from their chemical diet to produce the proteins and other components of their bodies directly from carbon dioxide. And this is essentially the same thing that plants do. They pull carbon dioxide out of the air and turn it into the larger carbon compounds that make up their cells, a process called carbon fixation. And that brings me to this chart showing atmospheric carbon dioxide concentrations over time. The first thing you'll notice is that the trend is steadily upward due to the burning of fossil fuels, and that's not a great sign for global warming. But the other thing you can see is the role of plants in the annual cycle of the seasons. So every year, when it's summer in the northern hemisphere, atmospheric carbon dioxide actually dramatically declines. But then we see this corresponding increase in the winter. And that points to one of the biggest drawbacks of biofuels like ethanol made from corn. Corn and other plants don't grow in the winter, so they can only fix carbon for half the year. That's where my microbes come in. They don't need light, and they aren't picky about seasons. As long as we give them enough chemicals to eat and a nice warm place to do it, they will grow and take up carbon dioxide. So the goal of my thesis has been to get them to make a biofuel at the same time, and at these extreme temperatures, which, although they would cook most living things, are actually more compatible with other industrial processes. So we've been able to identify a couple different biofuel pathways that can withstand these high temperatures, and I'm now in the process of putting these pathways into my microbes, where together with the native abilities they already have, fixing carbon, eating metals, this should allow us to make biofuels year-round from such unusual energy sources as the chemicals coming out of hot springs or waste metals left behind in mine tailings, or other energy sources we don't even realize we have yet. And that is how these heat-loving microbes can help us to keep the Earth cool. Thank you.